Welcome to Ask and Learn.
Hello student, in this problem a RL circuit is given, right? And we have to find out the phase shift of the circuit, of the circuit, and also calculate whether this phase shift is leading or lagging with respect to input and output, and also calculate output voltage V output when the input is 120 volt. Fine. So there are three quantity which we have to calculate: phase shift, whether it is leading or lagging, and output voltage also when the input is 120 volt. Okay, so for the phase shift, first we have to calculate the relation between the input and output voltage. Fine. So for this relation, we need to calculate the overall impedance of the circuit, right? So looking from this side, we can conclude that the resistance and the inductor is in series, right? And the series combination of these two elements are connected in parallel with this inductor. Fine, right? And the overall series parallel combination of in series with 40 ohm resistor, and the resultant of this system will be in parallel with this inductor, right? And the overall impedance looking from here is series with the 20 ohm resistor. So first we calculate from this side, right? So just remember that the impedance from this side, right? The impedance from this side is assume Z1, and total impedance looking from this side is Z2. Okay, from here is Z2. Fine. So first we calculated the Z1, then the Z1 will be, both are connected in series, this 30 ohm resistor and this 60 ohm inductor is connected in series. Then it is 30 plus iota 60, and the series combination of these two elements are in parallel with the resistor 30 ohm, right? So then Z1 equals to 30 plus iota 60 upon 30 plus iota 60. Fine. So by calculating this value, the resultant value of Z1 is 3 plus iota 21, and when convert this value in polar form, then the value will be 21.213 angle of 81.87. This is the impedance Z1 from this inductor to this inductor. Fine. And now we have to calculate the impedance Z2, then Z2 for this circuit, right? So the total impedance of Z1 is in series with 40 ohm resistor. So Z2 equals to 40 plus Z1, and it is connected in parallel with iota 10 ohm. Okay, so now calculate this value. Z2 equals to iota 10 into 40 plus Z1 upon iota 10 plus 40 plus Z1. Fine. Now put the value of Z1. It is iota 10 multiply. What about the Z1? Z1 is 3 plus iota 21, and 3 plus 40 is 43. Then 43 plus iota 21 upon iota 10 plus 40 plus Z1. What is Z1? 3 plus iota 21. Then by adding this value in this formula, it is finally 43 plus iota 31. Fine. So now by calculate this value, the impedance Z2 will be 1.535 plus iota 8.896, and when we convert this value in polar form, then the result will be 9.028 angle of 80.21. Okay, so we calculate the value of Z1, Z2, and the impedance Z2 is in series with 20 ohm resistor. So total ZTH, if we require total, then we can calculate total ZTH equals to Z2 plus 20 ohm, Z2 plus 20 ohm. Okay, so now ZTH equals to, what about the Z2? 1.535 plus 20, then it is 21.535 plus iota 8.896. It is clear? So we have calculated overall impedance of the circuit, right? Now we calculate the value of output voltage V0. Fine. So first we have to calculate the value of here. The value of here, and it is named as V2. Fine. And here the value will be assume V1. Okay. So first we calculate the value of V2. First we have to calculate the value of V2. Then what about the V2? V2 is simply, first we rearrange this circuit, then we'll show how to calculate the value of V2 and V1. So here we can redraw the circuit. This is 20 ohm and this is our Z2. This is our Z2 and this is input Vi, and here plus minus V2, right? So then V2 equals to, apply the voltage division rule. Apply the voltage division rule. Then the V2 equals to Z2 upon Z2 plus 20 into V input, and here we assume that over V input equals to 1 angle 0 degree, then V2 equals to, what about the Z2? Z2 is this value, 9.028 angle of 80. So we can write as 9.028 angle of 80.21 upon Z2 plus 20. So we use the complex value here. Why? Because of there are summation sign. Okay. So it is 1.535 plus iota 8.896 plus 20. So we can write directly here. Z2 means this value. So 1.535 plus 20 is 21.535 plus iota 8.896. Then the value of V2 will be 0.2066 plus iota 0.3277, and if you convert this value in polar form, then the result will be 0.3875 and angle of 57.77 degree. Fine. So this is the value of V2. Now we have to calculate the value of V1 from this side, right? So now again rearrange this circuit. Now we add this impedance only here. This is the Z1. This is replaced by the Z1 and this circuit will be same. Okay. So it is 20, 40 and inductor this one. So we can write again circuit. It is 20, it is 40, and here inductor. Okay, and this is the impedance of Z1. Fine. This is iota 10 ohm. This is 40 ohm. This is 20 ohm. And here the voltage is this value. Okay. So now we calculate the value of V1 here. Then V1 will be Z1 upon total impedance. Z1 upon total impedance. Total impedance is this branch circuit impedance plus this one. Okay, so it is Z1. So it is Z1 plus 40, Z1 plus 40 multiply by V2. Okay, so now by putting this value, V1 equals to 5, because of this voltage is drop across these two elements. Fine. So V1 equals to, what about the Z1? Or Z1 will be 3 plus iota 21 upon 43, total impedance 40 plus Z1 is 3 plus iota 20, so 40 plus 3, 43 plus iota 21 plus iota 21 multiply by V2, and V2 will be this one. Okay, V2 will be this one, 0.3875 angle of 57.77 degree. Okay, so now by calculating this value, your V1 will be simply 0.1718 angle of 113.61 degree. Okay, so this is the value of V1. Now again you can see the circuit, you find the value of V1 here. Okay, and now we calculate the value of V0. Okay, so V0 can be calculated by apply the voltage division rule for these two elements, right? So V0 will be, now we can write here for understanding, V0 will be this impedance iota 60 upon total 30 plus iota 60 into V1. Fine. So now we can calculate V0. We can calculate V0. This is equals to iota 60 upon 30 plus iota 60 multiply by V1. So now put value of V1. So V0 equals to iota 60 upon 30 plus iota 60 into V1. V1 will be 0.1718 angle of 113.61. Now by apply simple mathematical calculation, and the value of V0 will be 0.1536 angle of 140.2. Okay, so now we conclude that the output voltage V0 equals to 0.1536 angle of 140.2. Okay, so this is the output voltage V0. So in this question it is asked for the phase shift. Okay, so this angle will be our phase shift. This angle will be our phase shift. So our phase shift will be 140.2 degree. Okay, in second case they ask for it is whether it is leading or lagging. Okay, it is whether leading or lagging. Okay, so there are positive angle, okay, there are positive angle. So positive angle means your angle will be leading angle. Okay, so it is the leading phase shift. Okay, it is the leading phase shift. Okay, and in third case it is asked when if V input is 120 volt, then what about the output voltage? Okay, so this output voltage is when our input will be unity. Fine, our input will be unity, and for if input will be 120 volt, then we can simply multiply this value by 120, then the resultant output will be at the input of 120 volts. So then 120 multiply by previous output voltage, it is 0.1536 angle of 140.2 degree. Fine. So then result will be V output equals to 18.43 angle of 140.2, and this output is also a leading output voltage V naught, or we can say that the magnitude output voltage is 18.43 volt. Okay, this is the answer of our third problem. Okay, so what in this problem we have to first we calculate the effective impedance of the system looking from each and every section. Z1, it is represented by this circuit, and then calculate for the voltage V1 and V2, and then calculate the output voltage V0. In output voltage, the angle will be represented the phase shift, and if it is the positive angle, then it is the leading phase shift. And in third case, if input is 120 volt, then the output will be by simply multiply this output, because why? Because of it is at the unity input. Okay, so we multiply 120 of previous output voltage, then it gives our output voltage at the input of 120 volt. It is clear? Thank you.